Today is 9/6, September the 6th. What we're actually factoring today, here's the real name for the record. These are called quadratic form. That's the technical name. Notice I am not saying quadratics. They are quadratic form. And I'll explain to you what that means here in a second, the nature of what a quadratic feels like. What I will call them almost exclusively 100% of the time, math people usually call these lookalikes. And a lookalike is something that you already know, but kind of on steroids. And so when you see the first example, you'll kind of see what I mean. This first example is not all mega juiced up, but you'll recognize right away that like, ooh, well, that's a little different. But the feel of it is what I want to talk to you about. And then once it clicks, you're like, easy. And again, I'm keeping this very easy today because I'm trying to not make the mistakes I've made in the past of piling on too many layers too quickly. So just like yesterday, we practiced bare bones basic grouping. Today, we're going to practice bare bones basic lookalikes. And then next quiz, next chunk after Tuesday is where we start going bigger with all the mixed bag stuff. And so anyways, this is your first lookalike here. And I would ask you what's different, but I don't want to insult your intelligence. I don't like it when people ask me really dumb questions and then expect me to answer them. So clearly what you see is now we're dealing in higher powers, and it's not like it's cubes, and you can't look at it and say that it really fits into any category that we've talked about. It's certainly not a grouping problem. It's certainly not a quadratic, and it's certainly not a sum or a difference of cubes. Hence the fourth category today, this is called a lookalike. And what we mean when we say it's in quadratic form is just the feel of the exponents. What do you notice? This is an answerable question. What do you notice about the exponents? What else? I'm going to give you other examples where that's not necessarily the case. So just so you're clear, it's not that they're divisible by 2. You should see a pattern in the exponents. Yes, more specifically though, how does one transition to the next and to the next? What are you seeing in the patterns of the powers? Something like that, right? Let me just give you another lookalike. And I'm just going to make up one real quick, just so, because I don't want to steal example 2. But here's another lookalike. That's a lookalike. That is what we're learning today. That is a factorable quadratic form expression, not a quadratic form. What do you see in the exponents? How does one then become the second and then become the third? What do you see in?
Okay. 21 is when it times itself by, if it times itself by 2, then that's the higher power.
As another person might say, the second exponent is half of the first, right? That's what it means to be a quadratic form expression. If your second power is half of your first power and then your third power is non-existent, we call that quadratic form. And if you look back at even all the quadratics that we've done a lot already. This is a quadratic, by the way. That is a quadratic. And it is in quadratic form, but specifically it's called a quadratic. And what are the powers? What are the exponents on the white problem? What are my exponents? X to the 2, X to the 1. Hey, look, even exponent, half of that exponent, no exponent. That pattern makes you a lookalike. It makes you a quadratic form expression. So the question becomes, well, how in the world am I supposed to factor this? Well, it's actually remarkably simple. And that statement is, of course, predicated on the assumption that you know how to factor quadratics. So if you think about, okay, how am I going to factor this down? Well, I'm going to just follow what I know about quadratics, and I'm going to build two shells. And just follow your mathematical spidey sense here. What do you suppose we ought to put in the first blanks right here and here that very conveniently will multiply to make x to the fourth? I need x squared here, and I need x squared here. And I can now check worrying about x to the fourth off my list. I did it. There are other ways to make x to the fourth. Like you could front load it and put x to the fourth and 1, or you could put x to the third and x. Don't do that. To make this work, to match the quadratic form, you need to divvy that power half here, half here. And then the rest is just exactly what you already know how to do. Tell me about my signs in this problem. Just tell me about my signs. There has to be one of each. And again, if I'm any good at this job, I have gotten this point across to you that all you care about is the yellow number. If he is negative, then all you need to tell me, and which is what most of you said, is that one of them is positive and one of them is negative. I don't give a rip about the number in the middle. If the bad guy's negative, end of conversation. Mm-hmm.
Oh, we need to -5 in there somewhere.
We're going to make it. 3 and 8 should be coming to mind. Austin, how do you want it to break down? There you go. So you wonder about the -5, and I would tell you, whether you look at this and believe what I'm saying or not, you've done this 100 times. You just have never done it as a lookalike. You've done it as, in fact, if you aren't buying this yet, let me show you off to the side. This is the math problem that we just did. And there's no way you can tell me you don't know how to do that. That's factoring 101. That's okay, two shells, put an X here, put an X here, look at the number in the back. There's one positive, there's one negative. What two numbers multiply to make 24? I need a 3 and an 8, but a +3 and a -8. And you look at the red thing and the purple thing, and eventually you come to the conclusion, mathematically, that's the exact same feel. The one on the left, the purple one, is a quadratic form expression. The one on the right, the red, is a actual quadratic. So where this is going to go next level, and I left this, the one I murdered today in the notes, is where this is going to go next level is then these now are what I refer to as the offspring. Like they're the children of the original. So the original was x to the fourth -5x squared -24. His offspring are x squared +3 and x squared -8. Can you see how one of those offspring might become his own factorable expression? They're not. Because like x squared +3, there's no such thing as a sum of squares. Even if 3 were a square, I wouldn't care. And even x squared -8 is a difference of almost squares, but 8's not a square root. So that's what's not going to happen in today's lesson. In today's lesson, I'm not going to ask you to go multi-level. Today's lesson, we are just hammering and practicing the idea of factoring a lookalike down to its offspring. One step, done. And then next week, we take it deeper, deeper, deeper. So that's how you factor a lookalike. Let's go again, round 2. What makes this a lookalike? I just want to make sure that message, I talk a lot. I want to make sure you got that. Good. The powers go even number, half, none. So I recognize him as he's really just a buffed up quadratic. So pour some coffee and then you can answer questions while I pour coffee. When you build your shells, what are you going to put in the fronts of each shell? Right, x to the half as much as 10. Right, so we take that 10 and we divvy them up, basically just mimic the one in the middle. So we're going to put x to the fifths in both of our shells. We are going to have two negatives or two minuses because the number in the back is not enough information. If he's a plus, he says, well, all I can tell you is you're the same. And then the guy in the middle says, well, I can tell you they're both minuses. So we're going to put in a pair of minuses. It's still the same factoring know-how. It's just buffed a little bit. And what two numbers are we thinking of? 8 and 4 for sure. 4 times 8 makes 32, and 4 plus 8 also makes 12. There are other ways to make 32, but none of them interest us in this case because they don't add to make 12. So the pair that we're looking for is the -4 and the -8. And I came really close on this one to making this, but I was trying to catch myself today. Don't do this, dude. Don't do this. Fight the urge. That's really close to being a difference of squares. Why is it not a difference of squares? Sutter? Right. The odd exponent on 5 says you can't square root me. Like that -4 over there is really delicious looking. So enticing. But the x to the 5th is a deal breaker and says you can't break me down as a difference of squares. For me to be breakable as a square, I have to be x to the even power, like Sutter said. 4, 6, 8, 2, something like that. So this one is also dead. And this is what you can expect today. One step, done. One and done. Gone. Feel like you got that? Okay, a couple more. Shouldn't have any issues. Once it sets in, which I think for most of you it just did, then you just roll through it. You should have zero difficulties. Uh, I am going to write a new one. I'm going to call one more audible on myself here. So thank you, Javin. I don't want to either. I appreciate it. I was hoping someone would do that. So yeah. That man loves his geometry, that's for sure. Yeah. So no troubles, I assume. You went through just your normal thinking as far as how to factor a quadratic. You built your two shells, and then you put half of the 6, so x to the 3, x to the 3. You know that your signs are both pluses. There's no way around that. And yeah, 6 and 7 are our guys. Times tables to the rescue, right? 6x, 7x, 13, boom, done. All right. The last thing I can do to make this a bit more challenging for you is, of course, put numbers in front of the beginning. As you know, that's when factoring always takes the turn. So 2 more examples. Again, it fits the lookalike mold in the structure of its powers, even, half, none. So what changes this time is when we build our shells, it's a little bit less of a brainless process. We don't just cruise control through this. What am I going to put in my first one? 3x to the half as much. Good. And then the other one is our x to the half as much. And then the factoring thinking is still the same. What do we know about our signs? One of each. And we might have to switch them, but that's what erasers are for. Big deal. I like to just put them in, switch them. Who cares? Put them in lightly, maybe. And then we're looking through our times tables and thinking of what makes 20? What commonly comes to mind? Probably 4 and 5. That should generally be where normal people start, is real close, 4 and 5. So I'm just going to stick them in there. So let's say just pop in a 5 and a 4. Who cares? Does it work? I think we have to switch them because those make 5 and those make -12. And last I checked, unless I've been doing it wrong for a long time, 5 minus 12 is not 11. So the power of switching things. So perhaps if I take the 5 and the 4 and swap them for a 4 and a 5. And now I got to switch the signs. Again, you guys are really good at this. So you see things kind of before I'm even done talking, which is really good. So yeah, we get 4 in the middle, -15 on the edge. 4 minus 15 is -11. And you're like, ooh, cool. I got the right number with the wrong sign. So we need the -4 and the +5. So same. Right. Last example. And this is the one I just kind of called an audible and just whipped this one up because I didn't want you to get sneak attacked by this. So, and then it's work time. So this is the final sort of level, which you guys should probably be past the point of panicking about this, but what makes it last level, like final boss battle kind of thing? 3 and 2 or 6 and 1, right? Yeah, I knew what you meant. So that's good. So when the number in front is not prime, that's when you got to go. All right, I got a little extra meat on this bone. So we go into it not knowing if it's this. Go ahead. I would, and I always double up my templates. Some people don't set them both up. I do. I always just get them both out there in the open, and then I feel like I've got my workspace laid out. Tell me about my signs. Definitely. So I like it when things are for sure. I'm a let's be for sure kind of guy, and I like those minuses. Don't have to erase those. And now we're running through 28s. What's the first pair that you probably think of? 4 and 7 make 28. So I'm going to go there first. Which template do you guys want to try? Bottom, I heard. Okay, let's do bottom with a 4 and a 7. That's an 8 and a 20. Hey, we got it. First try. And again, if you by some chance haven't gotten this memo yet, you just have not been here. You do not get rewarded for making 6x to the 8th, and you do not get rewarded for making 28. You're big kids. The awesomeness happens when you just happen to go -8, hey, -29. I did it. So, and again, there's potential there to be a difference of squares. Don't you see it? That this first one is almost a difference of squares, but who's breaking the deal? That dang 3. If that 3 were gone, then he'd be a buffed up difference of squares. And that's again another day. So, any questions? Right. Simon's on the canvas. I think I published the page. If I didn't, let me know.